Good morning, Amber. I'm sorry you're having such trouble with those two problems from section 4.2, so I thought I'd make you a video and go over those with you, and I'll also include the handout that you're seeing on the screen here. So problem 13 is the one about the orders from the restaurants, and the question that they want you to answer is the probability of getting an order that is from restaurant A or an order that's accurate. And so you see the table here. This is the problem that you did that was marked incorrect. And I went ahead and I put the totals on across the rows and the columns that we're going to need. And the overall total for the table is shown right there at 1,109 orders. Okay, so let's let event A be the event that we get an order from restaurant A. And so when I look in the table here, I say there's 350 orders from restaurant A out of 1,109. So I created that fraction right here because we're going to use the addition rule. The probability of event A or B is equal to the probability of A plus the probability of B minus the probability that both A and B occur. So I'm going to find these three pieces and then I'll put them together into the formula. So the probability that we select a restaurant an order from restaurant A is going to be 350 divided by 1109. And then the probability that we select an accurate order, if we look across the first row, there's 977 accurate orders, so it's going to be 977 over 1109. Now, finally, we need to find the probability of getting an order from restaurant A that's accurate and is from restaurant A. And if we look in the table, we see there's 320 orders right here that were both accurate and also from restaurant A. So that probability is 320 divided by 1109. So now I can take those three probabilities and put them into the addition formula. So the probability that we get an order from restaurant A or that it's accurate is this fraction, which is the probability of getting an order from restaurant A, plus this fraction, which is the probability of getting an order from restaurant B, minus the probability of getting an order from restaurant A and that is also accurate, which was 320 over 1109. So if I go ahead and I add 350 plus 977 and I subtract 320, I get 1007 divided by the 1109, the total number of orders, and I get an answer of 0.908 with a lot of other decimals, but they want 3 decimals in the answer, so that rounds off to 0.908. So I hope this might help. I tried to figure out how you got 0.147. I really don't know. I tried to figure that out. I'm not really sure what you did there because I can't get that number to come out. The other one you seem to have trouble with was problem 15, which was the one where they give you the information in sentences and their suggestion or their hint is to put it into a table. And so this is the one about the results for a test for marijuana use, and they give you the positive results, the false positives, the negative results, and the false negative results. And I actually had sent you this handout previously, but let's go over it together. So we were told there's 150 subjects with positive results, and of these, 28 were false positive, which means they tested positive, but they don't use marijuana. And then we were also told there's 160 negative test results, of which there are 4 false negatives, which means they tested negative, but they actually use marijuana. So if I create the table down below here, and my columns are going to be positive test result, negative, and then my rows are going to be uses marijuana, doesn't use marijuana. So I'm going to start by putting in the total number of positive results, 150, and the total number of negative results will go over here. And so here's my table so far. So now they told me there were 28 false positives, which means they tested positive, but they don't use marijuana. So the 28 is going to go right here. And then they also told me that there were 4 false negatives, which means they tested negative, but they actually use marijuana. So that number is going to go right here. So here's my table so far at this point, right here. So using the information in the problem, I was able to put in the numbers in the table like this. And I also did the total across the bottom. Now I can fill in the missing cells by adding and subtracting. So if I go down here, I see that 150 minus 28 gives me 122. I put the numbers I added in here in red. And then 160 minus 4 gives me the 156. And then finally down here, I went ahead and added across the rows to get the totals for using marijuana and not using marijuana, 126 and 184. And I always like to check and make sure that also added to the 310 that I got by adding the 2 numbers across the bottom of the table, which it does. So now this is similar to the last question. You're going to use the addition rule. I'm going to find the probability that a person tested negative or did not use marijuana. So that's going to be calculated with the addition rule, the probability tested negative plus the probability does not use marijuana minus the probability they tested negative and they use marijuana. Okay, so the probability that they tested negative, so I go to my table, negative results were 160, and that's going to be out of 310, so that's the first fraction. and then the probability that they don't use marijuana, so no marijuana here, was 184 out of 310, and then minus the probability that they tested negative and they use marijuana, so tested negative and use marijuana, tested negative So I'm going to subtract the probability they tested negative and do not use marijuana. So tested negative and do not use marijuana is 156. So 156 over 310. So if I add up 160 plus 184, subtract 156, I get 188 over 310. And if I divide that, I get 0.60645, which rounds off to 0.606, which was the answer that was given in the problem, 0.606. All right, so I hope this helps. I'm sorry you're having trouble with this section. You actually did very well other than these two questions, but hopefully this review might help you get these last two questions correct.